Hello, today is Thursday, July 20th, 2023. This is the Secure Pod sync. We have Erran Carey here to do a demo of breach and attack simulation stuff.
Cool. Hey, y'all. So, as I was saying before the recording started, I'm just going to be going over sort of my previous demo and expand on it and show what was released with the sort of 16.0 milestone, some of the improvements with 16.1, and then sort of the future breach and attack simulation. I'm just back from some PTO myself, and I was also working on a borrow for the editor team. So there's not much in terms of feature improvements, but I'm definitely interested to see to chat with you all about how customers might use it, or if there's any breach and attack simulation features, or just capabilities I've used that maybe weren't used in other places for DAST or in other scanners in general. So yeah, I will jump straight in. So we should see a Safari window. And what I can do is I can go ahead and so we can see on the incubation team for my seg, what I do is I typically publish the videos. Bree, you already created an issue showing off the previous demo with the documentation link and the feedback link. I really appreciate that. So just going off the back of that with what dropped in 16.1. So we can see here that in 15.11, breach and attack simulation was introduced as an incubating feature. And for that release, it was very minimal and it relied on external scanner. So we used a tool Nuclei, and I added in supports of ingesting the scan reports from Nuclei and then converting that into the GitLab native format. And then from that, what I ended up having is the capability to add evidence of callbacks, because Nuclei has support for using a callback server called the callback server for Nuclei is called interact.sh. And so with interact.sh, what I had the capability of doing is listening with the interact.sh server, and then Nuclei has the capability of communicating with the callback server for DNS and HTTP requests. So I was able to like custom made exploit Nuclei templates which had exploited a particular vulnerability. And so if you had a custom template that exploited vulnerabilities and used the functionality for a callback attack, that would then end up in your GitLab security report. And what I did is I took the Nuclei output and then I converted it and mapped it into a DAST report. Nuclei sort of can iterate over multiple hosts, whereas typically DAST reports in GitLab are targeted towards one asset or one host. So it was a little bit clunky, but I proved out the capability of adding in additional details for, hey, I've performed out-of-band security testing. For those who aren't familiar, out-of-band security testing is when you're testing a connection to an external service. So if you're a victim machine, you've been compromised, an out-of-band request would be making a call to another third-party server. And so if you make a call to a third-party server, that proves exfiltration. And in terms of like the cybersecurity kill chain, that means that like that's sort of you get to the data loss prevention where you've hit the points where you've already been exploited, but they're also able to get data out of your system and to an external asset. And so that's where sort of the out-of-band security testing comes in play. And so now with GitLab 16.1, what was released is the capability of running there's a new template being introduced, which is called the BAS template. So breach attack simulation GitLab CI/CD template extends the existing DAST template. So it'll run GitLab's own browser, the browser-based scanner and analyzer. And once it's done, it adds in the capability of breach and attack simulation. And so if you've enabled it and you've enabled the breach and attack simulation feature flag, which again, if you use the BAS template, it does that for you. At that stage, then the DAST analyzer, the browser-based analyzer rather, will automatically perform out-of-band connection testing whenever it finds exploitation, such as code execution. And so that can be expanded to different types of our CWE checks, because we do different CWEs. And the benefit is, whereas Nuclei is much of the time Nuclei templates are targeted for one CVE. So like it's like for Nuclei, you maybe are targeting a WordPress server, and if it's a WordPress server and we detect that it's version 123, then we will say, hey, run this particularly, run this exploits, run this code execution, prove that I can call back out to this external server. Whereas with our browser-based analyzer, the benefit is that it's basing checks on CWEs. So if it sort of finds any indicators that, hey, we might be able to execute code here, then we can go ahead and say, hey, now that I've executed code, also try to exfiltrate data through that code. And so what happens is for example, if a JavaScript application, we detect your JavaScript, I'll inject a snippet with a unique identifier. And I'll just show the evidence here. We can see here that there's a correlation ID. And so that correlation ID is based on their particular request. So for each request, what I'll do is the browser-based analyzer will it'll create this injection. And so this injection here, we can see it's a JavaScript snippet. For those not familiar with JavaScript, this snippet is literally just it's wrapping itself in a self-wrapping function. So if this code gets executed, it'll pull in the standard library HTTP server on Node.js. And so if you're on a Node.js runtime, it'll pull down the HTTP client and it'll do a GET request to this HTTP callback server. And so HTTP :/callback in this case is that's the host and port I'm listening on. So within the execution of the Dash analyzer, we're running that inside of GitLab CI. And so on a Docker executor, we have the ability to run other service containers. And so I introduced a simple HTTP callback service it's very minimal, but it's ours and it's a greenfield project. So we can sort of tailor make it to, hey, listen to HTTP requests and whatever you get back, record it, and then also provide the ability for the browser analyzer to send a request with the correlation ID. And once that request has been sent with the correlation ID, the browser-based analyzer, as it's compiling the results and correlating different vulnerability findings, the browser-based analyzer would be able to send a message to the callback server saying, hey, I sent an attack with this correlation ID earlier. Was that compromised, or is that not detected? And so the benefit of having my own callback server is because I was able to add in that sort of like correlation ID based finding, as opposed to some callback servers such as InteractSH. InteractSH, essentially the default modes of operation there would be that you have a server set up for InteractSH, and then you create a client, and that client is going to be listening for any request that server gets. And then you have to do a lot of filtering and stuff. Whereas this callback server, I know when I do an attack, my attack is going to include a correlation ID. And so then for my so the browser-based analyzer should be able to talk to the GitLab callback server and say, hey, for this correlation ID, was I attacked? And that is included in the findings inside of the security report. So we can see here, then it's just right now, just including the destination, the protocol, and the correlation ID. But those details are actually from the callback server, based on, hey, yes, I got that vulnerability was successfully exploited. From that point, then, so we have this new callback server that can be run inside GitLab CI/CD, and so that's one new capability for breach and attack simulation that adds support for out-of-band security testing for any analyzer. It could be used if we wanted to use it for the proxy-based DAST analyzer. We could do that. If we wanted to use it for say the fuzzing, like the API fuzzing analyzer or the DAST API analyzer, it's generic, and we can use it for any of those. And I have some experiments where I started to look at using DAST API to do callback attacks as well. I think that's sort of the bulk of it. The documentation is a really good place. This is all user facing stuff. I worked to make sure like all of it was sort of documented as I went along and introduced new capabilities. And I talk a little bit about that, like enabling container to container networking, which I find super useful. With Dast, there's the ability there, but it wasn't extremely well documented in terms of how do I do this for my particular like runtime. Whereas with the breach attack simulation stuff, I added templates. So if you're running the templates, and it'll attempt to do it with sensible defaults instead of having to go and figure out what those values may have to be. Yeah, I think that sort of wraps up that piece. In terms of demo, Again, the video demo included some of the execution of the pipeline. So what I can do is if I go back to the previous demo, we can see one of the first things that will happen is we get back a callback, and so we test. Yep, that's a guy. Love my own voice. So what I can do is I can go to I have a Dast callback attacks demo repository. And so inside of here, I define a CI/CD template, which includes the Dast stage. What I actually do is there's two options. You can either extend the existing Dast job with this breach and attack simulation template. And so if you do that, then and you have to define the services for the callback server to use. And you have to give it an alias so that the Docker and Docker networking can the container you're attacking. So you have to. This is in the case of the vulnerable application is a container, like a service container you're scanning against, and so you scan the vulnerable app service container. It will then call out to the callback server over the Docker network, and then the alternative then is if we're using Dast with Bash, so I give support for doing a different job. And in that case, what you can do is you can just extend the default Dast job, which the Dast template provides. If you do not include a Dast template explicitly in your configuration, I actually automatically pull down the latest, the Dast latest GitLab CI/CD templates, and that's included through this through there. Then so whenever this pipeline executes, then we can see it'll trigger. We'll have multiple stages, and then depending on the configuration, what we can see then. Yeah, so we can see here that if you're running with the Dast with Bash job, it automatically attempts to do callback attacks because it is detected that we've enabled the breach and attack simulation feature flag. This feature flags for the Dast are essentially environment variable controlled, and the CI/CD template will enable those. Previously, whenever the first iteration of Dast breach and attack simulation went out, users had to configure a bunch of environment variables, a bunch of custom Docker images, but now it's just you just get the ability to pull in a callback server. So yeah, more straightforward. And then we can see there it will generate the artifact. And if we go to our vulnerability reports, what we can see is for my vulnerabilities. In the latest one, we can see that then boom, we get the vulnerability, which is called this injection templates with the correlation ID. One thing it does is I upgrade the severity of the vulnerability immediately to critical. There's conversations with the threat insights team around how to better sort of tag saying, hey, this has actually been exploited in your environment, as opposed to being a theoretically exploitable thing that is maybe critical, but really when you go and check it, you're not actually able to exploit it. Whereas so this here is just me saying, hey, I've raised it to critical because it's a step above these other ones that are not actually exploitable for whatever other controls or mitigations you have in place, even though we thought we detected it. So yeah, that sort of wraps it up. I'm totally open to questions now. I would love to hear y'all's feedback on it. And go forward.
Thank you. That was so cool. I have a couple questions in the docs, but I will wait on those if others have questions. Okay, I will ask mine and then let you answer them for the sake of the recording, because thank you for your answers. First question I thought was what kind of service would I use as a callback service? This wasn't quite clear from the docs. The demo might make it clearer, and it did make it clearer. I don't know if you want to say more about the callback server, because that's cool that there's a greenfield one.
Yeah, it sort of went over in the demo, but just for anybody going over the Q&A at the end, I'll just verbalize it again. So today, dynamic analysis, when you use a browser-based analyzer with the breach and attack simulation template enabled, there's a repository called callback, and so that's underneath the GitLab org project under the incubation project under breach and attack simulation. It sort of goes nested down into security products. Whatever we do, the 1.0 release will probably move it from my sort of breach and attack simulation namespace into the top level security projects or security products group. And once it's under that group, it'll just be called a callback on there. And so today, just go to the callback Docker image, and you can use that project to run. It doesn't need to be run as a Docker image. You can actually run the Golang binary directly, which can be useful if you're dealing with things like proxying or dealing with sort of like over the network connections, and you want to add, say, like enable HTTPS on top of it with like Cloudflare or something. So you can run that as a binary, and I've like played around with that in AWS and stuff, but right now it's not extremely easy to configure that, so it's not shipped with the template. But yeah, so the callback server is the go-to for now. Interact SH I've got some experimental support for, but I'm sort of focused on merging down my changes and getting them released in dynamic analysis like by default instead of like behind this breach and attack simulation feature flag.
Gotcha. That makes sense. It's very cool. I think you did kind of answer my other question, which was, do you have a demo BAS project we can experiment with today? And I think that's possibly one of the most exciting things about today is being able to get hands-on with this. So thank you.
Yeah, absolutely. Yeah, and again, that project is it's linked in the document, but dash callback dash attacks. So for any of my projects, it's almost always under the incubation engineering namespace under GitLab under breach and attack simulation. So once you drill that deep, you can sort of just like open the tree view and see the different projects there. But high level, there's like a demos folder, and then there's a security products folder. Security products are experimental scanners and features that eventually should be getting moved under the security products like top level group, and sort of published and have a regular release process and other maintainers. And then ones under demos are just really quick and dirty demos to show off features I'm experimenting on.
Sweet. That would be cool. We like demo projects, so thank you. I have a question that might actually honestly maybe be a feature proposal. I think what you said is like you changed the severity of this vulnerability from high to critical because the callback was successful. So I'm sitting here like, yeah, I would love in the UI to know a little bit more clearly, like that's why that changed. Is my understanding correct? And do you think like do you agree that would be helpful?
Yeah, absolutely. So yes, yes and no. So right now, in terms of what I do today, I just have a call out at the bottom saying, "Hey, this is the callback details," and I just, without the user knowing, I just changed the severity to critical. And so right now, I only support one or two different types of CWEs. And for those CWEs, I just take it from high to critical. I think both the CWE checks I support today are the ones that I support today are marked as high, and then I'm upgrading them to critical. The Threat Insights team though does have a couple of stories and feature requests in their backlog around there's one around like grouping vulnerabilities, which sort of covers this because what I could do is I can group all of my vulnerabilities that have been successfully exploited as, hey, these are exploitable, like like actually exploited vulnerabilities, compared to things like, hey, if there's CVEs that have been detected from a different type of security report, like say static analysis, then those could be saying, hey, likely exploitable. If it's a CWE that's like a CISA a CISA like known exploitable vulnerability. And so there's tickets in the backlog. There's a couple of tickets within the breach and attack simulation epic around this. But yeah, we want to show it in the UI somehow. But the way you've worded it, it's actually interesting to me. I almost see it as like a sort of like a pop over, like a tooltip, or even like a little like in the presentation there, show it. And
Yeah.
today the UI is doing the work and the lifting of showing the severity. There's no additional fields or like context inside the security reports. It might make sense to have a new field and the vulnerability finding. If we had a new field in the vulnerability finding to say, hey, this has been escalated or elevated.
Yeah.
Right now it's not available.
Gotcha. I will create that feature proposal.
That'd be awesome.
哦。
So is the plan that this feature will ultimately be fully integrated into Dast, or would it remain as kind of as an optional standalone thing as well?
Yeah, absolutely. So breach and attack simulation spans it. There's a lot of overlap with Dast, and so whenever I joined GitLab, I quickly partnered with the Dast team and dynamic analysis. They've been great stable counterparts, and so I quickly seen as a way to show exploitation that I could go ahead and work off their engine and add in additional capabilities. The sort of like future, the sort of grand scheme of things is I want to add supports for sort of attack surface management. um, and so, and when you have attack surface management in GitLab, like in the product, it sort of gives you the sort of overview of, hey, based on these different assets in my environments, these are the ones that I truly find critical. And so with breach and attack simulation, then what you can do is you can say, hey, these are my critical assets. Try to break into those, and what are the breach scenarios that an actual attacker would do. And so that's what breach and attack simulation is focused on. So the current the current sort of feature piece of the product is, yes, 100% that's going to go straight into dynamic analysis, and that will be maintained with their team, obviously, with reaching out to me as needed. But for breach and attack simulation, that's going to be its own standalone part of the product in the future. And that could be, and so today, breach and attack simulations pulling on things like vulnerability management, where we have a vulnerability report from Threat Insights, or it's pulling in from Dast, or it's pulling in from the like different like static analysis, etc. All these different scanners, and it's sort of just highlighting things. But eventually, there will be a sort of its own piece in the product where you go into the under the secure panel in your group, and then from the group level you can see, okay, for these projects, these are the different services that I have, and for those services, what types of scenarios may an attacker attempt to against these. And so that will sort of take into the context of, hey, this is a Java project. Oh, you have you have infrastructure as code, and because you have infrastructure as code and it's a Java project, let's check out what type of image you're deploying things on. So, oh, you're using a Docker image. Okay, cool. So you're using Docker. Let's check out the default values in your container. Oh, that container includes a vulnerable Java runtime. So now that you've got that context, we can then attempt to do exploitation from even the cluster level if you're running in a cluster, or it could be from like there's many different entry points, and breach and attack simulation is about giving access to view all of those. But yeah, short answer is yes, the current implementation of this sort of like the breach and attack simulation templates, which extends Dast, is that's all going to get put into the main branch of Dast and be enabled sort of behind a feature flag still, but we'll be enabling it by default, and then it can be disabled if you choose. And that again, it'll be enabled for like Docker runners. If you're running with Docker, that's like, and you want to set up a callback server, this is how you can do it.
Okay. And then presumably as you develop more breach and attack features, those will get rolled into this optional template within the incubation space. And so that fits
Yeah.
into all the warnings and stuff about it being an unstable component.
Yeah,
Right.
absolutely.
Okay.
Yeah, and I guess like things to look out for next in terms of what customers may want to use and look up is cluster with clusters and the Kubernetes integration and Kubernetes, like the agent for Kubernetes. That gives a really good way to say, hey, you've got running infrastructure, let me try to exploit it. And so from that stage, then we'll sort of like bubble up like, hey, these are the containers running in your environment, these are the deployed environments. And so giving sort of like doing an asset inventory. I actually linked inside as one of my questions. I actually linked a proposal from James Hebden. They're on our vulnerability management team, and what they've done is they've set up a proposal for like adding models into GitLab, into the database where we actually track assets, and so vulnerability findings can be associated with assets. And once that's there, then I gain some additional capabilities with breach and attack simulation. So I'm trying to collaborate pretty close with them there.
That would be big and interesting.
Yeah, James wrote a bit on an awesome proposal for anybody. Not, I think that's why everybody's quiet, because I've seen a few links clicking on that. The proposal is fantastic. James is great. I very much want to see what they continue to go on there. So yeah, if there's any further questions, please speak up now. Otherwise, like I can drill into a few questions that are around like from y'all's perspective as support engineers, what different capabilities may be useful. Cool. I'll go ahead and verbalize some of my talking points then. So the first one is so today with our security tooling with breach and attack simulation, what we find is that's the benefit of breach and attack simulation and the sort of end goal customers have when they want to look for a breach and attack simulation tool is not just exploiting stuff just for the sake of exploiting it and say, oh, that is exploitable. It's for highlighting real risk and what the actual vulnerabilities are affecting their environments and how severe those being present are. What pain points are you seeing the customers having with our security tooling in general, and in terms of like prioritization, and how and is there any ways you can think of breach and attack simulation potentially helping with this? And this is for the whole group.
I have had some instances where customers have a hard time getting the browser-based scanners to work, but I know there's been a lot of work put into that, and I've also had to I guess tweak some of those settings myself. It's been a pretty hands-on experience for some of those single page applications, and a lot of those issues I think come from just the browser-based events and like the logic inside of the scanner itself. And so that's one of the pain points I've had to deal with a lot myself, is getting I guess a smoother experience from the end user's perspective. Like I haven't been able to come across a ticket where there's just a single question, but when it's a browser-based scan, it's been more of a trial and error type of situation until we can get it to work. That's for me, that's been my biggest pain point.
Well, yeah, that's interesting. I definitely one of the things I got feedback on from the dynamic analysis team whenever I sort of set out to create my own like custom CI/CD templates is that they didn't have a lot. They have a bunch of projects for like benchmarking. These are like different open source tools and stuff like that you'll see competitors look at. And a lot of the time what those competitive tools is like say like WebGood or something, or there's like these various like down vulnerable web app. Those tools are more about like teaching a security practitioner like, hey, this is how you hack into something, and this is this vulnerability, and here's how you'd remediate the vulnerability. Whereas a lot of like dynamic analysis tool vendors essentially would do is they would say, hey, look, we cover 300 vulnerabilities in this software, but those 300 vulnerabilities may not actually be useful or help a customer prioritize issues. But again, because it ends up becoming a checkmark exercise when one analyzer is competing against a competitor, they'll say, hey, this competitor has 300 vulnerabilities, you only found 50, but the 50 vulnerabilities found may be more important. And so I definitely find that. And going back to my point is what the dynamic analysis team has been doing is trying to like look for templates and things like that, where like, okay, it may not work in this scenario, and like, okay, if it doesn't work in that scenario, how can we get like a reproduction environment? So I know like whenever I was like I remember one of the first I jumped on like a customer issue to see if I could help out the dynamic analysis team, is there was like a very specific Windows environment where like that was a server that we were scanning against, and that environment we couldn't quite hit points on. And so I guess the point is that yes, I can see that like for the browser-based analyzer that could be an issue. And I guess my question is like for those types of issues that we're getting, are we like trying to create reproduction environments, like minimal reproduction environments that like dynamic analysis as well as breach and attack simulation and other analyzers could use?
Some of those have been what I consider edge cases. I'm not sure what exactly was happening for the last one I can think of, but the customer was willing to share a public version of their page. And it just didn't coincide with the timing that the team had as far as the effort that could be put into that portion of the analyzer at the time. And so in my attempt to reproduce the problem was unsuccessful, and that's why I consider that to be an edge case. Part of the problems we were seeing, it was just navigating through the site. Like there were weird timeouts on browser-based events and stuff that I honestly couldn't make much sense out of. And we weren't able to reproduce any of those things. Like I even created a single page application using the same stack the customer was using, and I had no luck with that. And after some tweaking, it worked. It's just the tweaking experience of those timeouts and values and stuff. I guess that to make that a little less painful, it could be a little bit more like having a more lenient option when it comes to timeouts. Like some people don't mind that a scan runs for 3 hours if it's gonna go through the whole page. And some people do care about the performance of the scanner. But for the most part, just getting it to work from, for once, and then getting to the, I guess, optimizations is more important for some people. And I don't believe we have that, flag where it can run for an indefinite amount of time yet and spend as long as it needs on timeouts and whatever. Like, I know it doesn't make a whole lot of sense from a code perspective, but from an end user's perspective, just getting it to run successfully once is a big first step. And then optimizing, timeouts and stuff could be a secondary thing for them. But yeah, for that type of experience, like end users don't have that much. I guess there's not a whole lot to go off of, like understanding what needs to be tweaked and why that needs to be tweaked as far as timeouts or like depth in as far as the navigation of the scanner and stuff like that. I think they need a lot of experience with browser-based scanners to understand what those settings are and why they're even there in the first place.
Yeah, I think this gets it back into the realm of the dynamic analysis team. So I'll try not to comment too much, but like I can definitely appreciate the pain points there. Like with you even going through and trying to debug and troubleshoot with your customer. One thing I would say though is recently I introduced the ability to add in configuration options and reports those configuration options up through the sort of snowplow metrics. There's actually some pending changes, so I don't think it's enabled by default. But what we get though is if the security we add the ability for analyzers, this and for DAST it is enabled inside of the analyzer, where the analyzer will include in the security report configuration options. And so, but that list of configuration options is an allow list inside of the scan the security reports. So each analyzer configures which configuration options they want to add. But I would say, like, would it make sense for you to go and create an issue for adding for those timeouts to be included in that security reports? And then what you could do is as soon as you open up, obviously you can go and look at the sort of templates and sort of like bubble up to say like, hey, okay, the template has the default options or it doesn't have set this environment variable. Whereas if you enable in the security reports, those options will always report in the security report as for what was actually used. And that obviously provides a benefit as opposed to like, hey, let me go through all the environments variables. Let me go through the default options inside of the source code. So I would say like, hey, let's add those timeouts that we're seeing customers needing to tweak to get that sort of first success. And like, let's create an issue for reporting that upwards. And like, I'm happy to like give you feedback on like that issue. I guess if you just want to title it, like even like CC me in the issue, but like just tag it as something like include the timeouts, DAST timeout variables in DAST reports. And then that will there's configuration options as part of the like I added the support for reporting configuration options. And obviously, if you want to look at doing a contribution yourself, I can sort of get you the MR where I added a recent configuration option and started tracking that. And yeah, I can obviously, if you create that issue, I can tag you and let you know. But eventually, what we'll have is we'll have GitLab reporting that through Snowplow and those bubbling all the way up. So we can look in our CSense dashboards for customers who have enabled tracking of their metrics. And so we can go and look at CSense dashboards to see anonymized versions of the different options. So for sensitive options, for example, there's like an authentication URL. What we have is we actually have supports for saying, hey, this is a sensitive option. I just want to know if it's set or not. So it doesn't actually track the value for string values in some cases. It just says, hey, yes, there's a configuration URL. Yes, it's been set, and no, it's not been set. And that just gives an indication based on the security report saying, hey, yes, this customer is using this value. And if we know that the customer is using the value, or like this is like with CSense in the dashboard, it's obviously not tracking for particular customers, it's all anonymized, but you get to see like, hey, a lot of customers are using URLs, like the URL option, and for scans with the URL option enabled and the timeout set to this, maybe like it's breaking or something, right? So you get into like being able to do some dashboards and sort of like analysis based on that. And then for like looking at particular reports, it helps with like debugging it from the support perspective, I would imagine.
Yeah, having those options and reports, that's like one of those, like, that's amazing ideas. We should do that. Ulysses, will you create that issue or shall I? I don't care. I just want to make sure it gets done because I think we need that.
Yeah, no, I got you. I'll
Okay.
create the issue, and I'm even
Thank
looking
you.
forward to potentially creating an MR for that because it sounds really useful.
Sweet. Aaron, would you mind, and it can be after this, linking the MR that you talked about where you started adding configuration options to security reports? I would be curious to take a look at that if you can
Sure.
easily find it. Thank you.
Yeah, my next points in the documents, yeah, if anybody has other pain points in mind, we can talk a little bit about that. Let's see. So that's the Igloo side. So yeah, I think. Oh, yep. So I'm just saying what public MRs have been there is for the actual browser-based analyzer. That repository is private still, but yeah. So this MR here, this MR is actually going through and adding. This one adds a few different flags, but basically what we can see in it though is that, like, hey, we've added the scan options. So the scan options, like then formatting the scan options, that's not going to be required anymore. For the next MR, what would have to happen is, so for any feature flags, we automatically add _feature flag, and we're going through and adding that. So those are all Boolean values, and so if any feature flags were passed in for the scan, we'll automatically get all the feature flags being explicitly passed true false values. And then for ones that have like been explicitly set in configuration to a non-nil value. So if you like, if it's nil or null, and we treat that as like if it had been emitted. Whereas if you try to set it true or false, we'll report the value in the security reports. And so that's true for all scans going from the version that this merge request is tagged in going forwards. We can see then there's also the scan options append. And so these scan options are those configuration sort of options. And so we can see that we have this bool configuration value for auth URL, and then we have this full scan, so that's a bool. And so for adding a new one, you just go ahead and you can create the sort of you can create a new test if you need to for end to end. But then you can also just go ahead and add the options in. If you add an option to be tracked, that is used in other scans, it will automatically populate these all. So there's the team has already dynamic analysis team has already documented how to regenerate test expectations. Now that for you, that will automatically generate the correct expectations for you in terms of like, hey, I added a third option, like include that in this test results. And that otherwise you'll get a failure saying like, hey, this like didn't expect this value to be here, now it's there. So we can see here that it just goes like this, and then those are my test expectations. And then yeah, off the back of that, then we can also see like going through, and I think there should be a unit test as well at the end, where yeah, we can see here that for this I've added in like test scan options with this. So if I format the report with this config value set to false, then we can assert that there's a like an element in here in options, the report options, to say that yes, that's been set to true. And then we can see different unit tests here around that. So yeah, that would essentially be what the MR would look like. It'd be a lot smaller than this. This is obviously when I've added 3 options, and I had to update the tests for like some of the options were used in all scans, basically like full scan, for example. That's going to be set to true or false in the majority of scans, as opposed to being entirely omitted. So we can see there that you'd be able to just go ahead and add in. What I'd recommend is like the sort of whether it's been set, whether it's empty, and whether it's absent. And so those are like the 3 cases. Like if you set it to empty value, do one thing. You just test what what you want to like make an assertion about, like what way you expect it to be. Hope that helps you, Ulysses.
Sweet.
Yeah, and then I guess if there's anything in terms of like breach and attack simulation that you've heard from customers, I'd be keen to know what type of questions they're asking around that. And that could be penetration testing as well as breach and attack simulation or attack surface management. It all falls under similar umbrellas, and like I've from specific goals in mind with breach and attack simulation, but a lot of the time it's like overarching and different like security testing. Like customers are asking for security testing, like are they'll ask for like a specific type of security testing, but really they want like just a way to prioritize or visualize like certain components of the attack surface. And so I'm not trying to be super strict in the definition of, oh, this is only breach and attack simulation tools. Like this can't be done because that's like an attack surface management thing, or this feature that they're asking for, it's an like interactive like application security testing. Like it doesn't need to be extremely like explicit. Just giving the ability to have better sort of prioritization over your attack surface is what I'm going for.
I will say I haven't heard much from customers on this, and Erran, that's part of why I wanted to talk to you to get a better feeling for what was here and when to suggest this to people and for what purpose and that kind of a thing. I don't know if anyone else has heard from folks on it. I should have checked for tickets. I will do that. I will do that after this. Yeah.
Yeah, I guess one way I could word it that may be more of a common thing is for false positives. You all get a lot of questions around false positives in terms of like, hey, I scanned this thing, but I'm not actually vulnerable, but you said I got this critical vulnerability. Is that something we see fairly often?
I can certainly see that coming up in terms of particularly also with the competitive scanner thing, where how come our other scanner doesn't say we're vulnerable to this and yours does, that sort of thing. There's all sorts of variations on that one. But I can't remember I can't remember which scanner it was, but I definitely remember doing a ticket along the lines of, our third-party scanner came up with these 50 issues and you only came up with 5. And there were entire classes of issue, like TLS vulnerabilities, for example, which our scanner's much more narrow than that, whereas this one's are like all the things,
Yeah. And I'm sure for the TSL, I'm sure the TLS vulnerability included each cipher suite as a different vulnerability finding. So you already got vulnerabilities from that.
Yeah.
But communicating that understanding to people is that's tough. Like, here's why that you can't just compare numbers.
Yeah, absolutely. I find myself referring back in I think it was Isaac. I think it was Isaac's blog post around introducing the new browser-based analyzer. I think Cam had some involvement in the blog post, but I think Isaac is marked as the author for it, and Isaac Dawson. And so it was around, and I'll grab the link like offline as well. But the blog post is like, hey, we're introducing this new browser-based analyzer. Here's what it does. It's the feature introduction blog post. So it was in like the GitLab release blog. And so it talks about, hey, this is the browser-based analyzer. Here's the benefits of using it versus the Zap-based proxy analyzer they were previously using. And the main thing is this is a modern analyzer that's looking for modern vulnerabilities. So for things that your browser protects you against, right? So if it's like a TLS vulnerability, things like that, that is true and it is a problem. But if you're using a modern browser, that's not an issue. So as a good security practitioner as the security team and the IT team, an organization could just put a policy on their assets. So their assets have to use specific browsers, and those browsers have software on them to monitor and make sure that those misconfigurations are not available. And so once that's done, then obviously you get into the like, okay, now the browser-based analyzer can find the real like nitty-gritty things. Like you can find the actual vulnerabilities that are like an issue with your application that can lead to data loss or lead to exfiltration of data to like an external source. And so like I always try to go back to this blog post and share that with folks that are like getting into the numbers game of, oh, this competitor got like this many more. And then another thing we do, like the blog post like literally spells out like, here's the three top reasons why we have less number, like a lower number of vulnerabilities. But that's good. And then it explains like I think there's a few use cases. The ones that come to the top of mind are modern vulnerabilities, so things that are actually vulnerable and like a secure browser will not protect against, and it's like an issue with the server. Then it's like aggregation of vulnerabilities. So if we find several vulnerabilities related to one configuration option, and you can add that configuration option to your server, and you've updated that in your application, and once you do that, it will resolve all those vulnerabilities. That family of vulnerabilities will be aggregated into one, in some cases, the browser-based analyzer, which is really confusing for customers because customers are used to seeing like hundreds of vulnerability findings in some scanners, right? But when our scanner says, hey, this is like a group of 20 things, but it's only one vulnerability, and we're only showing you the number one, that is like, oh, hey, like what's going on there? You know, it's like they play the numbers game, and competitors try to do that sometimes. But it's very much like, hey, like, do you want 100 vulnerabilities that you can't prioritize easily, or do you want to be able to prioritize 10 vulnerabilities for things that we know are like modern issues that aren't protected, that are likely not protected against in your environment otherwise? And then breach and attack simulation obviously goes further than what dynamic analysis does, where it goes like, hey, we think you're vulnerable to these, or hey, we've done like a basic exploitation against it, your application. Whereas breach and attack simulation goes like, hey, I've done an exploit. Now go ahead and do like a malicious exploit with like a basic scenario. Obviously malicious in terms of like a test scenario where the customer's opted into it, but it's like, hey, this is like, allow me to run this breach and attack simulation testing like against your software, and like we'll see, hey, can I create like GCP credentials? Okay, can I revoke those? Like, hey, I have permissions to destroy this, right? And like highlighting that to the customer, that's where like BAS comes in. It's like that's very much, and I'm sure I can keep like rambling on there, but I think that would probably like more than answer the question.
That sounds so cool. That sounds so cool. Erran, thank you so much for the time. We are at time, so I will thank you all and stop the recording.